So we use concentration, lots of different units. We use molarity, ppm, percentages, all of these things to measure concentration. When we're looking at the acidic or basic characteristics of a solution, we oftentimes talk about pH, which is just a way of reporting the H plus concentration in a particular solution. And what we see is that pH varies greatly. We see things that have a neutral pH, so blood's pretty close there in the middle there with 7.4, and we know that's a pretty small range. We look at some other samples here. We go down to coffee as 5. We'd start to look at juice and soda, very acidic things, getting down to lemon juice. So acids have a very sour taste. So we see when we take a bite out of a lemon why it's so sour, because the acidity is so high on it. It has very high levels of acid in it. Battery acid, even lower pH. On the other side, we start to see neutral things. We see baking soda, 9.5. This is often kept in labs to neutralize any acid spills. Ammonia solution, so NH3 is the compound there. That's what ammonia is. So weak base. Moving on up to things like bleaches and drain cleaners, so much higher pHs. So a lot of our cleaning products and soaps actually have basic pHs. So what we see here is just a comparison of some H plus concentrations in solution, which remember H plus still means the same as our H3O plus. Okay. Those are the same thing. We're just using the shorter version, the H plus. So we have our concentration of the H plus in the solution, and we can actually calculate the pH. And so we'll talk in just a second about how we do that, so you can try that out on your calculator. But one thing I want you to notice here is that if we're looking at values, so I've got 1.0 times 10 to the 0, notice that my pH is 0. Here I've got 1.0 times 10 to the second, my pH is 2. 4, 4, 6, 6, 8, 8, and so on. Now, if this value isn't 1, then it's not going to be exactly 0 or exactly 2, but it'll be pretty close. And it's just a way to kind of decide, is this a reasonable answer? So if I have something that's 4.5 times 10 to the 6, I know that that pH is going to be somewhere near 6. If I got a value of 1, I would be a little suspect about that value, or about that answer. So here is the equation that we're going to use to calculate the pH of solution. And so we use pH equals negative log of H plus. Now the question always comes up, why do we take the log of a number? Well, when we take the log, we don't have to worry about a number in scientific notation. Remember that when we took the log of a number, those examples you saw on the other page, we got nice whole numbers and not very small or very large numbers. And the negative sign is there because we're typically dealing with very small numbers, and if I take the log of a very small number, I get a negative value. And so by putting that negative sign in there, we made the value positive, because we don't like keeping up with negative signs. We don't like dealing with really small numbers. And so that's really the reason why we do pH instead of just saying the H plus concentration. So pH is just kind of a shorter way of saying the same thing. Kind of like how we say a mole means we have 6.022 times 10 to the 23rd of something. It's much easier to say I have a mole of something than I have 6.022 times 10 to the 23rd of them. So here we see the same scale. Now we do have pHs that go into the negative range. We're typically only going to see things in this range, and for most things when you're working with something like blood, you're going to see it right here in this region. If we look at what's going in our stomach, that's gastric acid that has a pH of about 2, and we see different pHs or different substances with different pHs. So sig figs are a little bit different when we're dealing with logs and finding the pH. So what I look at is I look at my original concentration of my solution, so my H3O plus concentration. If it has 2 sig figs in the value, these numbers, the scientific notation part, doesn't affect the sig figs. If we have 2 sig figs in the value, then I'll have 2 decimal places in my answer, in my pH. And this is just an effect of the way logs are calculated, and we're not going to get into that here, but know that if we have 2 sig figs, that means 2 decimal places for our value. And so if we had 3 sig figs, we'd have 3 decimal places, and so on. So now we're going to look at how you actually calculate the pH on your calculator. So make sure you're using your calculator and it's going to be the one you use on the exam. There's kind of two approaches on different calculators to enter these values. So you might have to play around a little bit to see which one works for your model. If you have the TI-30X2S, I think it is, the one that I recommended, you're going to use the first method. If you have the other TI kind of 30, it's usually black or gray, you'll use this method. If you have a different model, you might just kind of have to play around. But what we're going to do is we're going to find the pH of a solution whose H plus or H3O plus, same thing, equals 3.2 times 10 to the minus 3. Now from this, we know that our value is going to have to be somewhere close to 3 because we have that exponent of minus 3. So our pH is going to have to be there. And I'm going to tell you that our answer is 2.49. That's the pH of our solution. So the way you enter this on your calculator is some models you're going to hit the plus or minus sign, or it may show up as a negative sign. You're going to hit the log button. Notice there's a log and there's an LN, which is a natural log. You want to make sure you hit log, and then you're going to type in your H3O plus concentration. When you type that in, make sure you're putting this number in scientific notation, so that will probably look something like 3.2 EE to the minus third. So we're going to put it in this way because we want to make sure that the calculator is treating it all as one number and taking the log of this number and not just taking a log of the 3.2. If you get an error message doing that, or it doesn't give you the 2.49, check again. You may need to enter your concentration first, then hit log, and then hit your plus minus sign to change the sign. So play around a little bit, pause here until you get to this value on your calculator. Now, if we have the H3O plus concentration, going to pH is pretty straightforward. It's a little bit different going in the opposite direction. What if we know the pH and we're trying to find the H plus or H3O plus concentration? So remember, pH and H plus are very closely related. They're telling us about the exact same solution. They're just reporting the value in a different way. And so we can actually rearrange our equation here. Here we have pH equals negative log of H plus. So that's the equation that we look at to show the relationship between H plus and pH. Now I'm going to move my negative sign over, so I essentially divide both sides by -1, because remember, whatever I do to one side, I must also do to the other. So I have negative pH equals the log of H plus. Now here's the tricky part, which you may not be familiar with. When we have the log of something, the opposite of that function is taking it to the power of 10. Just like addition and subtraction are opposites, multiplication and division are opposites, the opposite for log is taking it to the 10th power. So I can take 10 to the minus pH, 10 to the log of H plus, because I'm doing the same thing to both sides, and as a result I get 10 to the minus pH, but what I see is that 10 to the log of something essentially cancel each other out. Just like if I multiply by 2 and then divide it by 2, I get right back to the same value. So say I had 5 times 2, which give me 10, divided by 2, and I get right back to 5. So 10 and log are opposite functions and they cancel each other out. And so this is what we're going to worry about at the end. I just wanted to show you how we got there. So if you're great at math and you like algebra, you might not want to have to worry about memorizing this final step, this final version of the equation, and you can do the derivation as you go along. If you're not comfortable doing that, by all means, please just learn this version and this version as well, so that you know how to get back and forth between pH and H plus concentration. So here's another one to let you try on your calculator. We're going to do the opposite here. We're going to find the H plus concentration given the pH. And being given the pH is not that odd of a thing, because what we see is a pH sensor or pH meter is very good at determining the pH very quickly. And so if we measure a solution's pH and find it to be 8.42, but we need to get back to the H plus, then we need to be able to do that calculation. And so again, I'm giving you the answer. I want to make sure you do this until you get the answer that you see here. And so this has a little more variation on how you're going to see this on your calculator. For some people, when you look at the log, you'll see above it a little button that says, or a little symbol that shows it as 10 to the x. So you're going to take second log minus sign, or the plus minus sign pH. You can also type in 10, so 10 to the minus pH. For some calculators, if you use the second method from the first question we asked about this, you're probably going to have to do this. We enter the value of the pH, then you hit the negative sign, then you take second log of that. So play around this, figure out how to do this on your calculator, the one you're using on the exam, so not your graphing calculator, and see if you can get to these answers. If you're having trouble, okay, two things. One, you're welcome to come see me and be able to and I'll be happy to help you sit down and use your calculator. If you're having trouble finding a particular button on your calculator and you want to look at this, take a picture of it or find the model of it on Amazon and send the link and post that on Piazza, and I'll be happy to help you kind of find the buttons and we can figure out how you do that on your particular calculator. So again, make sure you can do both of these types of calculations on your calculator. If you have any questions, please post them on Piazza and I'll be monitoring that through Thursday and beyond.